Hi Sec 3s, today I'll be going through Kpt Worksheet 1. I shall not go through the first 3 MCQ questions because I think they're relatively simple, but if you got them wrong, right, please look through them again. Okay, so now let us look at question 4. So the question asks you to describe the arrangement and movement of chlorine molecules. So I believe most of you didn't know that chlorine exists as a gas at room temperature, but I guess if you learn more chapters along the way, you should be able to tell lah. But maybe not at this point yet. But not to worry about that. So for arrangement, right? There's actually two parts in when we actually describe the arrangement of particles. So the first thing to take note of, right, is the particle spacing, the spacing between the particles. Then the second point, right, is to tell whether the arrangement is regular or disorderly. Okay, so do take note. So there's 2 points to answering the arrangement of particles. Okay, so next, for movement, right, movement talk about the movement, how fast they move. So whether they are vibrating and rotating slowly or moving at high speeds. And then here we can also say in all directions. Okay. Okay, so one thing to take note, right, for the movement of particles in a solid, right, a lot of you tend to miss out this portion here, which is the rotating portion. Okay, so a lot of you, right, always give me like this vibrating about fixed positions, but then you guys always forget this portion here. So vibrating and rotating is two different things. So actually vibrating means you are actually like kind of like a sideway movement. Rotating, right, is like you're moving in a circular motion. So actually particles in a solid state, they do rotate about their fixed positions. So take note, right, you have to use both phrases in your answer, vibrating and rotating. Okay, so in this question, right, the way you should answer it, right, is like let's say motion from what to what. Okay, so this is how you should answer it. Motion change from what to what. Then arrangement, right, change from what to what. So this is how you should phrase your answer. Okay. Okay, if not, right, let's move on. So here I think part A, a lot of you, for question 5A, a lot of you managed to point this out, that they melt over a range of temperature, or you can simply say that the melting point is not fixed. So I'm glad most of you are able to point that out. Okay, so for here, right, same thing as just now. So movement and then arrangement. So movement, right, so first state, right, movement from what change to what. Okay, then arrangement, right, change from what to what. Okay, so similar logic lah. Okay, so for here, yeah, so do take note, right, for liquid, the movement is sliding past one another freely throughout the liquid. Then arrangement, right, closely packed, but do take note, right, the closely packed in a disorderly manner. Okay, then for part C, you guys should point out this part, that the impurities, right, can cause harmful side effects. Okay, so that's why for drugs, right, it's important for us to have close to 100% purity if possible. Okay, for 6A part 1, in your figure, right, you should show me that your particles are both closely packed and also in a disorderly manner. Okay, so please show, I have to see these two elements inside your drawing, so then I'll mark it correct. Okay. Then for part 2, right, I think a lot of you didn't reply to this, didn't answer this portion about why liquids have a fixed volume. Okay, so the reason why liquids and solids have fixed volume, right? The fixed volume portion is due to them being closely packed together. Okay. Then then after that you will make the however portion, which is to distinguish between solids and liquids. Why liquids, right, have no fixed shapes? Because the particles are able to slide over each other freely. Okay. Okay, so similarly, right, for part B at the bottom here, you have to show me that in a solid, right, the particles are closely packed. The first thing is closely packed. Then second thing is orderly arrangement. Okay. Then for gas, right, you must show me that they are far apart and disorderly manner. Okay, so you need to show both elements in your drawing, right, for me to give you the mark. Okay, next part, the last question. Okay, so a lot of you are able to point this out. So the process is sublimation. A lot of you managed to give the correct answer. For part 2 and part 3, right, it was quite poorly done because I guess most of you are not familiar with how to use energy change to describe a change in state. Okay, so first thing, right, always mention that thermal energy is absorbed or released. Okay, so look at it in terms of energy first. Is there energy gain or energy loss? Okay. Then after that, explain that thermal energy, right, is being converted into kinetic energy. Okay, so in this case, right, you can say if it cools down, right, the kinetic energy is lost from the particles, but if the particles are being heated, right, it gain kinetic energy. So after that, right, link to the movement of the particles. Okay, so say that with this increase or decrease in Ke, right, what happens to the motion of the particles? Then right, then afterwards you have to, the second portion of your answer, right, should talk about at this transition temperature. So at the point where the change in state occurs, be it like melting, boiling, freezing or condensation. Yeah. So at this particular point, be it the melting point or the boiling point, what happens at the molecular level, at the particle level? What happens to the forces of attraction because of this increase or decrease in Ke? Yeah, so explain that portion. Then after that, right, list down the change in the motion of the particles. Okay. Then after that, right, link it to the final arrangement of the particles. Then the second part of this question, right, we have to explain in terms of temperature. Okay, so with that in mind, right, what happens to the temperature? So we always have to link back, right, to the concept where since thermal energy, right, in this case during a change in state, right, it's not being used to increase the kinetic energy of the particles, but rather to overcome the forces of attraction. So with that in mind, right, because there's no increase in Ke, and then since Ke is proportional to temperature, there will be no change in temperature. Okay. Okay, now for part 3, right, what happens to the temperature of the cooler bag containing dry ice and ice cream? Okay, so the temperature of the cooler bag should reduce because in this case, when dry ice actually goes through sublimation, right, the kinetic energy, once the kinetic energy of the particles is used to overcome the forces of attraction, right, the particles of air and ice cream will have lesser Ke. So if there's a decrease in Ke, right, the temperature of the contents will decrease. Okay, so in this whole question, part C, right, always link to the energy. So how energy affects the motion and arrangement of the particles. Okay.